Now, the last part of the notes, and don't in some ways be fooled by the fact that it's only a small section at the bottom. You'll see quite a few of the past papers will have questions on this. And it's one that at the time that it was going on to the syllabus they liked quite a bit because it illustrates two things. First of all, an extraction of metals process that basically has less environmental impact and also uses basically a scrap material to try and extract the copper. Now, the first thing to say is that think back to what we had just done in terms of the extraction of copper. So copper can be reduced by its ores by heating to high temperature with carbon. Now, disadvantage that works best, remember, with the high percentage copper ores. So any of the ores that have lots of copper in them. It also requires heat, which invariably comes from burning fossil fuels, and therefore basically is going to release carbon dioxide into the atmosphere, and therefore is going to be high energy requiring, and also potentially global warming. The carbon dioxide going into the atmosphere, increasing the amount, and therefore increasing the global warming. The process that we're describing works best with low-grade ores, those with only a small percentage of copper in them. And this is quite often even things like waste. So, for example, mines that previously had closed because it was uneconomical to extract the copper, they can go and get that ore. Or it can be from sources just that maybe don't require just as much processing. So, therefore, it makes it a relatively cheap process to carry out. It also uses scrap iron, and scrap iron again would be relatively cheap, so it's all simply to be collected and then can be used, and therefore it's relatively cheap and widely available. Now, the process basically has two parts to it. The first thing is, remember that the ore contains copper. So what we want to do is we want to get it in the form of copper ions. So if you like, we've got the metal in there. It's an uncombined metal because copper is low in the reactivity series, or something that can easily be dissolved out in a +2 state. And you could use something like hot acid and so on, but the environmental process, we're trying to reduce the amount of energy that's required for this. And the way that they do it is a dilute acidic solution, usually sulfuric acid, and it contains an enzyme that's extracted from a bacteria, and the bacteria Thiobacillus ferrooxidans, so basically something that's called a bacillus bacteria that can basically take iron and it can sort of use that as an oxidation process. So what it'll do is it'll take the copper from the ore and bring them out in the form of copper ions. So this treatment will extract Cu2 plus ions. Then from that, what we're trying to do is we're trying to get our copper metal. So the copper ion, Cu2 plus, will basically be reduced by gaining electrons. So there again, we're going from the +2 in the copper to the 0. So there's the reduction process. And to do that, we'll have iron. Now, iron will basically do the opposite. It'll start off as Fe. It's higher up the reactivity series, so it'll donate the electrons to the copper ions and become Fe2+. So the iron is going to be oxidized, and at the same time the copper ions, Cu2+, are going to be reduced. So why is that, and as you see it, inverted commas, the term environmentally friendly? Well, I suppose there's three reasons at least behind that, and you can list these down here in your notes. So first one is it works with lower grade copper ore, so therefore it may be easier to extract the copper ore. You're not going for the ores that are basically deeper down and rejecting lots and lots of ores. You can use lower grade ores, so it's maybe more economical with resources. It is low temperature. It's got a bacteria enzyme in it, and therefore has to be low temperature, so therefore there's going to be a lower energy requirement, and the less energy we require, therefore the less fossil fuels we're going to burn, and that's going to be more environmentally friendly, if you like. And the other thing as well is that we use a scrap material, scrap iron, which basically will mean that we're using a waste material, and therefore it's more economical with resources.